All right, now that we have grouped our measurements into constructs and constructs into group constructs, one little detail that still remains is how do you calculate the correlation between these quote unquote created or virtual, however you want to name it, constructs or group constructs and other existing variables, other measurements, other constructs within your correlation table. Let's try to understand this through an example. So here I have measurement 1 and 2, which have created construct 1, and I have an external variable. It could be a measurement, construct, group construct, whatever. Here I have measurement 1 and measurement 2 and variable A. The correlations I have is the intercorrelation between my two measurements and the correlation between this and variable A between measurement 1 and variable A. Now I group these two measurements and create a new variable, which is called construct number 1. And the correlations that I do not have and need to be calculated are the correlation between each of these measurements and the created construct, but more importantly, this one between the created construct and the existing external variable A. So how do you calculate this stuff? These are called composite scores. Composite scores are correlations between a created variable and an existing variable. So to calculate composite scores in HubMeta, we use the methods provided in this book by Frank Schmidt and John Hunter. This is Methods of Meta-Analysis, published in 2015. And in chapter 10, they have a subsection called Conceptual Replication and Composite Scores, and they provide all the formulas for calculating these composite scores. And these are the formulas that we have used in HubMeta. And believe me, it can get very complicated. In some cases, we have used many different tests to make sure that the numbers are right. But of course, if you found any errors in it, or if numbers didn't make sense, make sure you write to us. We will look at it together. So to do this in HubMeta, let's just use the example we had right now. And let's just open up any paper here. Let's add data entry. And let's say a sample of 100. Remember this calculation type. I will talk about it in a second. Let's create my sample and add a bunch of rows. I will choose measurement 1 and measurement 2. Remember, we want to do this model right here, measurement 1 and 2. And for this, I will just choose construct 2 in our project. So here is construct 2. I will do some example numbers. It really matter. And 0.3. And yeah, I think this is good. And go ahead and click on save. Now, when you save that, you will see that two lines are automatically added. These are grayed out, means you cannot edit these lines because these were calculated by HubMeta. These are your composite scores. So as you can see, it gives me the correlation between measurement 1 and construct 1, between measurement 2 and construct 1. These are these two in our picture, which we're missing. And also this last one, which is between construct 1 and construct 2, which is this guy right here. In addition, what happens in this case is that, remember, we had already grouped construct 2 and construct 1 into group construct 1. So HubMeta is automatically calculating composite scores for this one too. So down here, you see how composite scores are calculated for that. This is an extremely important option that you have within HubMeta because it's almost impossible to calculate these composite scores manually. And it even takes HubMeta a very long time when you have a very big project and lots of different variables. So sometimes when you change the groupings between variables, you have to give it some time for all the composite scores to be calculated. So this calculation type actually is the way composite scores are measured. By default is set on auto, and the default method is HubMeta composite, and it's Hunter and Schmidt method, which uses those formulas for calculations. So if you choose this one and click Save All, as you can see, values are calculated again, and these are the composite scores you can see. You can, however, change it to normal average, in which case it's not using any specific formula, it just averages things out. So let's see how it does that. If you do Save All, this is simply the calculated composite measure. It's just the average of these two correlations. It's not very sophisticated. The reason we have that, and the reason we have this auto, and we recommend you always use auto, is because in some cases you might not have enough data. There might be a lot of missing values within your correlation table. In those cases, the composite score calculation formula from Schmidt and Hunter doesn't work properly. It creates nonsensible values. And this is based on our experience in some specific cases. So usually we will set it on auto. In cases when the numbers that are produced do not make sense, for example, when you have a lot of missing values, you will change it to normal.